Hello there, and welcome to The Ancient Historian, where curiosity gets cozy and science takes the scenic route to slumber. Tonight we begin a journey not forward but backward into the deep history of our planet. Our focus is a time long before people, long before cities, long before even the faintest whisper of human imagination. We're going back over 300 million years, to when Earth's face was utterly transformed, when all the land we know today was locked together, fused into one colossal landmass called Pangea. Imagine closing your eyes and peeling away the familiar outlines of continents, the jagged coasts of Africa, the sweeping arcs of South America, the frozen crown of Antarctica, the deserts of Arabia. Erase them all. Now, picture them drifting like puzzle pieces across a black ocean, slowly sliding, grinding, colliding, until click they snap together into one enormous shape. That is Pangea, a supercontinent that dominated Earth from roughly 335 million years ago to 175 million years ago. It is almost impossible to overstate the strangeness of this world. To stand upon Pangea would have been to stand in the middle of a planet reimagined. There was one ocean Panthalassa, vast, horizon-devouring, circling the entire Earth like a watery crown. There was one landmass, Pangea itself, stretching from the polar ice to the equatorial furnace. No matter where you walked, you were still on the same giant body of land. If this kind of quiet, wandering question stirs your curiosity, I'd love to hear from you. Drop a comment below and share where you're watching from, and what time it is there right now. It's incredible to imagine people all over the world, each following this journey through time together, like scattered sparks tracing the edges of history. If you feel drawn in, tap like or subscribe. It helps this little signal ripple outward, reaching other curious souls moving through the world like shadows chasing sunlight. No pressure. Think of it as a soft invitation, like a drifting feather settling on a hidden path, or the faintest whisper of a story carried on the wind, guiding us somewhere strange, secret, and entirely unexpected. So settle back, let your mind wander, and follow this thread wherever it leads. Now, let's step into this alien Earth. Picture yourself standing somewhere near the heart of Pangea, in what we might now call the interior. The land stretches endlessly in every direction. Mountain ranges claw at the sky, carved by ancient collisions of tectonic plates, while vast deserts expand outward, seas of sand reaching further than the eye can follow. The climate here is extreme. The farther you move inland, the drier and hotter it becomes. Without modern oceans breaking the land into smaller regions, rain struggles to reach the center of the supercontinent. Storms hug the coasts, but the heartland bakes under relentless sun, creating one of the largest deserts in Earth's history, rivaling even the Sahara today. But wander outward, closer to the edges where Pangea brushes against the great Panthalassa, and the world shifts. Coastal regions bloom with lush greenery, marshes, and swamp forests where primitive plants stretch tall, feeding herds of strange animals. This is a land alive with movement. Giant amphibians lumber through muddy rivers, while the early ancestors of reptiles scuttle across fern-covered ground. The air itself is different, thick with humidity and carrying far more oxygen than today, a breath that fuels creatures of immense size. Now tilt your gaze upward. The skies of Pangea are unlike anything we know. Dust storms swirl across the dry interior like living walls of earth. Seasonal monsoons unleash torrents of rain, so violent they carve canyons overnight. And when night falls, the stars above shine on a world united, their cold light spilling across a land so vast it feels infinite. Walk further, and you'll stumble upon towering mountain chains, remnants of collisions that created ranges larger than the Himalayas, birthed as continents crashed together. These mountains were the backbone of Pangea, a skeletal spine running across its middle. Valleys between them cradled strange ecosystems. Forests of tall conifers, fern prairies stretching far and wide, and insect life that grew to astonishing sizes. Imagine dragonflies with wingspans as wide as hawks, beetles thick as your hand, and millipedes that could stretch longer than a person is tall. And then there were the animals. The Permian period, which overlaps with Pangea's dominance, gave rise to bizarre and haunting forms of life. Picture the Dimetrodon, not quite a dinosaur, but a reptile with a great sail rising from its back, basking in the sun like a living ship. Or the Gorgonopsids, predators with saber-like teeth and a gaze that once hunted the plains. These were rulers of the land before dinosaurs, strange experiments in evolution's endless workshop. The supercontinent also changed the rhythm of Earth itself. Ocean currents were redirected by the sheer size of the landmass. Weather patterns warped, and ecosystems shifted dramatically. The seas teemed with ancient sharks, armored fish, and coiled ammonites, their shells shimmering as they drifted through Panthelas's depths. Closer to shore, reefs flourished with early corals and sponges, creating underwater kingdoms beside the harsh, dry interiors of Pangea. Now imagine the scale of migration. On Pangea, a creature could, in theory, walk from what we now call North America to Africa without ever crossing an ocean. Herds of reptiles roamed endlessly, their tracks pressed into mud that would harden into fossils we still find today. Predators followed, shaping the eternal dance of survival across a land without true borders. But the story of Pangea is also one of tension. Beneath its massive surface, Earth's plates strained, grinding and pulling in ways invisible at first, but inevitable. Volcanoes belched ash into the sky, spreading layers of fire across the land. Rift valleys opened like wounds, hinting at the fractures to come. For though Pangea seemed permanent, it was not. Slowly, silently, it began to tear apart, piece by piece, until the outlines of the continents we know today emerged like ghosts from stone. Long before the age of dinosaurs, before even the first mammals scurried across Earth, the planet's surface was restless. Imagine a world where continents are not fixed, but drifting, floating on a molten sea beneath them, colliding and grinding like colossal puzzle pieces pushed by invisible hands. Around 335 million years ago, these wandering landmasses began a slow, unstoppable journey. North and south, east and west, plates of rock pressed forward, meeting, folding, and buckling under unimaginable force. This slow dance of continents would culminate in the formation of Pangea, the first true supercontinent. Visualize it. A continent stretching from pole to pole, its sheer scale bending your mind. To the north, land that would one day become North America and Europe, pressed against one another. To the south, the pieces of what we now call South America, Africa, Antarctica, and Australia collided, fusing into a single massive block. Mountains soared where land met land. The early Appalachians in North America, the Hercynian ranges in Europe. Peaks that would rival anything the planet has seen since. Valleys and basins formed, carving paths for rivers and lakes, shaping the first interior landscapes of this immense world. And the oceans, the vast Panthalassa shrunk in some places, expanded in others, pushed into complex shapes by the encroaching continents. Where land rose, the seas were forced into narrow channels, creating strong currents, swirling whirlpools, and tides that licked at newly formed coastlines. Imagine standing on one of these coasts, the water stretching as far as the eye can see, yet the nearest land hundreds or thousands of kilometers away. A distant wall of rock rising from the horizon. The climate across Pangea was unlike anything today. Because the supercontinent spanned so many latitudes, extremes dominated. the interior baked under relentless heat, dry winds sweeping across deserts hundreds of kilometers wide. Along the coasts, however, humidity and rainfall allowed lush swamps and forests to flourish, pockets of life clinging desperately to water sources. The contrast was staggering. Deserts and frozen highlands, tropical marshes and towering forests, all on the same continent, each a stage for survival and evolution. The forces creating Pangea were titanic. Tectonic plates collided with a grinding, screeching violence too slow for a human eye, but relentless over millions of years. Volcanoes erupted along plate boundaries, spewing ash and lava into the sky, changing the atmosphere, and occasionally triggering short-lived ice ages or warming events. The land shook, mountains folded, and the surface of Earth seemed alive, restless, almost aware of its own creation. Life on this emerging supercontinent adapted in remarkable ways. Early amphibians roamed the wet swamps, their lungs and limbs evolving to traverse both water and land. Reptiles began to dominate the dry interiors, exploiting spaces no amphibian could survive. Plants pushed upward, spreading across fertile lowlands, coating the barren interior with fragile greenery. The patterns of rivers, lakes, and floodplains became highways of migration for creatures large and small. Meanwhile, the collision of continents trapped enormous seas and lakes in interior basins. Water evaporated under the scorching heat, leaving salt flats, mineral deposits, and arid plains that would influence climate for millions of years. These landlocked environments became testing grounds for adaptation. Creatures that could survive drought thrived, while others perished, leaving only fossils and the echo of evolution's relentless hand. The sheer immensity of Pangea meant that weather and wind patterns became extreme. Cyclones and storms could cross thousands of kilometers unbroken. Snow fell at high altitudes in the poles while monsoons swept across lowlands, and deserts sprawled unchecked for hundreds of kilometers. Rivers carved canyons, deltas formed at inland seas, and mountains redirected entire storm systems. Every inch of land became a canvas for Earth's power and creativity, painting landscapes of both beauty and deadly challenge. Even the oceans responded to the birth of Pangea. Panthalassa's currents shifted with the continent's advance, sending cold and warm water surges around the globe, influencing the climate far from the land. Coastal ecosystems teemed with early fish, primitive sharks, and ammonites, their patterns shaped by changing tides, currents, and salinity. Along the coastlines, tidal flats and shallow seas became feeding grounds for life, while inland rivers nourished forests and deserts alike. And as the continents fused, the world became a single interconnected stage. From the icy poles to the tropical equator, life moved, adapted, and interacted in ways never before possible. Migration paths opened for some species, while others became trapped, isolated, or driven to extinction. The collision of continents didn't just create mountains and oceans. It set the stage for evolution, for climate, and for the incredible drama of life on Pangea. Step deeper into Pangea, and you begin to understand just how unlike our modern world it truly was. One glance, and it becomes clear that climate was not uniform nor gentle. The sheer size of the supercontinent created extremes on a scale that boggles the imagination. In the interior, hundreds or even thousands of kilometers from the ocean, temperatures swung violently. Scorching heat baked the lowlands under a sun that seemed larger, brighter, more relentless, and at night, temperatures plummeted as heat escaped into the atmosphere, leaving a bitter chill that could freeze rivers and trap life in a fragile balance between survival and extinction. Deserts sprawled endlessly across the heart of Pangea. These weren't merely sandy dunes. They were vast, cracked landscapes of stone and clay, sculpted by winds that could howl for days without interruption. Sandstorms roared like living walls, moving across plains and valleys, covering the ground in layers of shifting dust. Yet even these harsh interiors were not lifeless. Hardy plants clung to riverbeds or ephemeral lakes, their deep roots reaching for water trapped underground, their leaves evolving to conserve every drop of moisture. Insects, small reptiles, and amphibians exploited these oases, living in hidden crevices and burrows to escape the punishing heat. Travel toward the coasts and Pangea's story changes. Here, where land met Panthalassa, rainfall was frequent, storms were turbulent, and the air was thick with humidity. Swamp forests stretched endlessly, filled with towering horsetails, ferns, and primitive conifers. The wetlands were alive with amphibians, some the size of modern-day crocodiles, gliding through murky water while insects buzzed overhead. This was a sanctuary of life, a place where even the largest predators could hunt, and the tiniest creatures could hide among dense foliage. Pangea's polar regions added yet another layer of intrigue. Ice sheets were smaller than during later glaciations, yet still formidable. Seasonal light brought long months of darkness followed by extended periods of sun. Plant life was scarce, but the few that existed were remarkable in their adaptations. Lichens, mosses, and hardy shrubs persisted in the frozen soils, supporting a limited but vital food chain. Small animals, burrowing or hibernating, exploited these microhabitats, surviving in a delicate balance that felt almost miraculous. Even the oceans were shaped by climate extremes. Warm equatorial waters allowed reefs to flourish along Pangea's coastal margins, while cold currents surged from the poles, carrying nutrients far into the tropics. Shallow seas became nurseries for fish and mollusks, while deeper waters were home to early sharks and ammonites, drifting through a liquid expanse influenced by winds, tides, and shifting landmasses. Ocean currents were redirected by the sheer presence of the supercontinent, creating eddies, whirlpools, and powerful flows that could alter coastal climates dramatically. Life in the interior of Pangea adapted in fascinating ways. Reptiles, the rulers of the dry lands, evolved strategies for coping with drought and heat. Many species developed scales that minimized water loss, while some burrowed beneath the scorching surface to escape both predators and climate extremes. Predators followed prey with astonishing precision, moving hundreds of kilometers across the land to hunt herbivorous creatures feeding near rivers or seasonal oases. Migration was a matter of survival, dictated entirely by the availability of water and vegetation. Rainfall patterns were wildly unpredictable. Monsoons formed along the coasts, sending sheets of water racing across flatlands, while inland, months passed without a single drop. Rivers could swell in days, carving deep canyons, then shrink to thin streams that barely nourished life. These extremes fostered creativity in ecosystems. Plants produced seeds that could survive long droughts. Amphibians burrowed or estivate for months, and insects developed life cycles timed perfectly with the seasons. Mountains, born of continental collisions, also influenced climate dramatically. Their peaks intercepted moisture, creating localized rain shadows where deserts expanded, and valleys where wetlands and lakes could form. Winds funneled through these ranges, intensifying storms and shaping migration patterns. Life was forced to navigate not only vast distances, but also treacherous terrain, learning to survive in environments where one wrong turn could mean death. The incredible diversity of ecosystems on Pangea was therefore a direct consequence of the supercontinent's size and geography. Coastal wetlands, arid interiors, polar zones, mountains, rivers, and seas all coexisted within a single landmass. Each ecosystem shaped the next, connected by migration routes, rivers, and seasonal rhythms. Life was intertwined in an intricate dance, driven by climate extremes that alternated between nurturing and punishing with little warning. From above, Pangea might have appeared as a single endless land, yet within it, entire worlds existed: miniature climates, hidden forests, desert oases, floodplains alive with movement, and icy highlands harboring life against all odds. This was a world in flux, a landscape of power and mystery, where adaptation, survival, and evolution played out in breathtaking and often brutal detail. As we step further into the vast expanse of Pangea, life begins to reveal itself in astonishing detail. In the arid interiors, small pockets of greenery cling stubbornly to rivers and oases, and each plant, each fern, each primitive tree is a triumph against the relentless heat and dryness. Imagine vast plains dotted with tall horsetails, spiny lycophytes, and the earliest conifers reaching skyward, their needles adapted to conserve moisture. These were not mere backdrops for life. They were essential actors in a complex ecological drama, providing shelter, food, and the first signs of stability on a volatile continent. Near rivers and lakes, wetlands flourish with a riot of colors and movement. Mosses carpet the muddy banks, algae floats on the surface, and spore-bearing ferns sway in the warm, humid air. Amphibians dominate these areas, their bulging eyes scanning for prey, their strong limbs allowing them to leap from water to land in search of insects or smaller creatures. These waters were alive with motion, a silent pulse of life that would shape the course of evolution for millions of years. Reptiles, too, make their first bold appearances, adapting brilliantly to the supercontinent's extremes. Some, small and nimble, dart across the forest floors, while others, larger and more imposing, patrol the open plains, hunting with patience and precision. Imagine the thrill of watching a predator carefully stalking its prey, moving with a calculated grace, its movements perfectly attuned to the rhythms of the land and the seasons. Life in Pangea is a constant negotiation between predator and prey, a dance of survival etched into every footstep and claw mark. In the skies above, the first winged insects flit from plant to plant, pollinating and spreading life in ways that will forever change ecosystems. Dragonflies with elongated bodies skim over marshes, their translucent wings catching the sunlight, while primitive beetles crawl along tree trunks, their hard shells glinting in the warm light. Each creature is a master of its niche, perfectly designed to exploit the resources available, yet constantly challenged by both climate and competition. The seas surrounding Pangea's coasts are equally mesmerizing. Shallow coral reefs and tidal flats teem with early marine life. Ammonites coil through the waters with hypnotic grace, trilobites crawl along the seafloor, and primitive sharks patrol the currents, their sleek bodies cutting through the waves. The interplay between land and sea is vital. Nutrients flow from rivers to oceans, supporting food chains both above and below the waterline. Every tidal shift and storm surge reshapes habitats, creating opportunities for survival and evolution. Even in the most extreme regions, life finds a way. In the deserts, hardy plants bloom briefly after seasonal rains, providing fleeting nourishment for insects, small reptiles, and early mammal-like creatures. In polar regions, lichens and mosses cling to exposed rock, sustaining tiny insect populations and the occasional burrowing animal. Life is persistent, adaptable, and relentless, finding refuge in the smallest microhabitats that offer even a glimpse of stability. And then there are the extraordinary creatures of the Permian period, moving across Pangea in impressive herds or solitary dominance. Dimetrodon, with its iconic sail, basks in the sun along riverbanks, regulating its body temperature in ways that hint at the sophistication of life to come. Gorgonopsids patrol nearby plains, their powerful jaws and saber-like teeth ready to seize any opportunity. Herbivorous synapsids graze cautiously, always aware of the predators lurking nearby. Every interaction is a story of life, death, and survival playing out across a landscape still forming itself with every tectonic shift. Even at night, Pangea pulses with life. Bioluminescent fungi glow faintly in damp forests. Insects hum softly, and amphibians croak in rhythm with the trickle of distant streams. The air vibrates with energy, a constant reminder that this world, though ancient and untamed, is alive with movement, adaptation, and the ingenuity of life finding its place. In Pangea, ecosystems are interconnected in intricate ways. Rivers feed forests, insects sustain reptiles, and plants stabilize soils while providing shelter. Every organism, from the smallest moss to the largest predator, is part of a network that balances precariously yet brilliantly against the backdrop of an ever-changing supercontinent. Life is not static. It moves, adapts, migrates, and evolves. Each day a new challenge. Each moment an opportunity to thrive or perish. Step into the open plains and dense forests of Pangea, and you feel the pulse of a world alive with tension and anticipation. Every rustle of leaves, every shadow crossing the ground is a potential predator, a potential meal. This is a world where survival is not just a challenge, it is the defining rhythm of life. Predators and prey exist in a delicate, deadly ballet, each movement, each decision, dictated by instinct, hunger, and opportunity. Imagine a herd of herbivorous synapsids grazing cautiously near a swamp-fed river. These creatures are built for speed and vigilance. Eyes on the sides of their heads, ears tuned to the slightest sound of movement, tails flicking with nervous energy. Their survival depends on the subtle cues of the environment. A change in wind direction, the snapping of a twig, the ripple in the water. Across the plains, gorgonopsids, predatory therapsids with powerful jaws and saber-like teeth stalk silently. They move with a patient, calculated grace, muscles coiled and ready to strike. Every hunt is a test of patience, timing, and precision. In dense forests, predators take advantage of cover, using the shadows and undergrowth to hide from their prey. Imagine the flickering light through prehistoric ferns, the interplay of sun and shade, as a dimetrodon silently approaches a watering hole. Its sail rises and falls with each breath, an ancient thermal regulator, while it calculates the perfect moment to strike. Meanwhile, small amphibians and reptiles scurry through the ferns, their survival dependent on speed, camouflage, and the tiniest misstep of a predator. Across Pangea, life adapts in remarkable ways to balance predator and prey. Some creatures develop armor or spines to deter attacks. Others evolve heightened senses, allowing them to detect threats long before predators arrive. Migration becomes a vital strategy. Herds move across vast distances in search of water, vegetation, and safer grounds, always one step ahead of hunters that follow their trails relentlessly. You can almost hear the pounding of feet across the plains, the rustle of vegetation, and the sudden, terrifying burst of speed as predator meets prey. Nightfall brings a new layer of complexity. Nocturnal hunters emerge, exploiting shadows and cooler temperatures. Amphibians call from the banks of rivers. Insects buzz and flit unseen, and the faint glimmer of moonlight illuminates silhouettes of creatures moving stealthily. Predators like early reptiles and gorgonopsids patrol silently, their movements almost ghost-like, while prey animals rely on vigilance, burrowing, or blending into the forest floor. The night is alive with danger, yet teeming with opportunity for those bold enough to seize it. Along rivers and wetlands, aquatic predators patrol, hunting both in water and on land. Fish with armored scales, early amphibians, and semi-aquatic reptiles dominate these habitats, creating a dynamic interplay between land and water predators. Ripples across a pond might signal the approach of a predator, while a sudden splash can seal the fate of an unsuspecting herbivore. The edge of every river is a theater of life and death drama, repeated countless times across the supercontinent. Even small insects and arthropods play a crucial role in this predator-prey web. Their movements sustain food chains, feeding amphibians, reptiles, and even early mammal-like creatures. Pollination, decomposition, and predation on smaller species all intertwine, creating a network where the disappearance of one species could ripple across an entire ecosystem. Pangea's ecosystems are a web of life, fragile yet astonishingly resilient. In mountainous regions, predator-prey dynamics are even more extreme. Narrow valleys funnel both hunter and hunted into proximity, while cliffs, ridges, and ravines create natural traps or escape routes. Prey animals develop incredible agility to navigate these terrains, while predators learn to exploit the geography to their advantage. From above, you can imagine the intricate dance. A predator circles, a prey senses the threat, a chase unfolds over rugged terrain, and every decision can mean survival or death. Across deserts, plains, forests, and wetlands, these interactions repeat endlessly. Migration, hunting, and survival shape the evolution of species, driving adaptations that will echo through millions of years. The stakes are high and the tension palpable. Every shadow hides a potential threat. Every sound is a warning, and every step must be measured. Life in Pangea is relentless, raw, and endlessly fascinating. The world of predators and prey on Pangea is not static. It is a constantly moving, breathing drama. From the largest herbivores grazing in cautious herds to the smallest insect navigating a leaf, every creature plays its part. Each day is a story of survival, innovation, and the complex relationships that bind an entire supercontinent together. As we move deeper into the vast landscapes of Pangea, it's impossible to ignore the forests, wetlands, and scattered pockets of vegetation that define life across this. Unlike today's orderly ecosystems, the greenery of Pangea is untamed, sprawling, and almost theatrical in its diversity. Towering conifers sway in the wind, their spindly branches reaching toward the sun, while ferns, horsetails, and club mosses carpet the ground in thick, soft layers. Imagine walking through these prehistoric forests. Sunlight filtering through the canopy, shafts of light illuminating a world alive with the movement of countless creatures, each dependent on the vegetation around them. The climate dictates much of what grows where. In the interior deserts, plants are sparse but remarkable. They cling to moisture pockets in valleys, their roots stretching deep into cracked earth. Leaves adapted to minimize water loss, and reproductive cycles timed with rare, fleeting rains. These survival strategies are marvels of evolution. Picture a desert fern patiently waiting for weeks, then exploding into green life after a single shower, feeding the insects and small reptiles that have also evolved to endure these extremes. Life here is tenacious and almost miraculous, surviving against odds that would crush most species today. Along riverbanks and coastal wetlands, vegetation takes on a lush, almost tropical abundance. Swamps teem with enormous ferns, tree-like horsetails, and primitive conifers forming dense stands. The air is humid and fragrant with the scent of wet soil, decaying plant matter, and pollen carried by the wind. These ecosystems are alive with sound and motion. Amphibians croaking from hidden pools, insects buzzing through the foliage, and reptiles stalking carefully along muddy banks. Each plant is part of a delicate web, supporting countless other species and offering shelter, food, and camouflage in a world where survival is constantly tested. Forests in temperate regions of Pangea provide incredible diversity. Imagine a canopy stretching tens of meters above the ground, where sunlight warms patches of leaf litter, while shadows conceal predators lying in wait. Early ferns and cycads dominate, their fronds forming a labyrinth that creatures must navigate with care. Some animals climb or burrow, others roam freely across open glades, but all rely on plants for sustenance, protection, and the subtle rhythms that guide migration and hunting. The interaction between flora and fauna creates an ecosystem that is not only functional, but also breathtakingly intricate, a living tapestry that has evolved over millions of years. The poles, though colder, harbor their own unique vegetation. Lichens, mosses, and hardy shrubs cling to rocky terrain, forming microhabitats where insects and small amphibians can survive. Seasonal variations bring months of darkness followed by long periods of light, challenging life to adapt in extraordinary ways. Imagine walking through a polar woodland of Pangea, the ground covered with frost, sparse greenery glowing faintly in the soft light, and creatures adapted to extremes moving silently across the frozen soil. These regions show the incredible flexibility and resilience of life on the supercontinent. Plant life in Pangea is not just static scenery. It shapes the climate and the very air we imagine around it. Vast forests release oxygen, absorb carbon dioxide, and influence rainfall patterns. Swamps and wetlands create local humidity that can sustain ecosystems hundreds of kilometers away. Even the smallest plants, mosses and ferns growing along riverbanks, play a vital role in nutrient cycling and supporting life, feeding insects that feed amphibians, which feed reptiles, which in turn sustain predators. Every leaf, frond, and root is part of a massive interconnected system that defines life on the continent. Rivers cutting through forests bring nourishment and migration pathways for countless species. Imagine amphibians hopping across mudflats, insects carried by water currents, and reptiles drinking cautiously from calm pools. Seasonal floods enrich the soil, creating fertile patches that allow plants to grow even in marginal areas. Life is never static. Water, sun, wind, and soil interact constantly, shaping ecosystems that are dynamic, unpredictable, and stunningly complex. Even within deserts and drylands, plant life is surprisingly intricate. Succulent plants store water, tiny flowering plants bloom after rare rains, and roots twist and tangle to reach moisture trapped deep underground. These oases are lifelines for insects, small reptiles, and early synapsids, concentrating life in areas that might otherwise seem barren. It is here, in these extreme conditions, that the true ingenuity of nature is on display. Survival is not granted. It is earned through adaptation, resilience, and sheer persistence. The scale of vegetation on Pangea is mind-boggling. Forests stretch for thousands of kilometers uninterrupted. Rivers weave ribbons of green across deserts, and coastal wetlands pulse with life. Mountains rise above forests, affecting rainfall and wind, creating microclimates where unique ecosystems flourish. Life is everywhere, yet nowhere is predictable. The supercontinent is a stage of constant evolution and movement, where plants and animals are locked in an intricate, never-ending dance. Walking through Pangea's forests, deserts, wetlands, and polar regions, one cannot help but feel a sense of awe. The scale, diversity, and resilience of plant life shape the survival of countless species, dictate migrations, influence climate, and create the very rhythms that define life. Every frond, every leaf, every root is a story of survival, adaptation, and the beauty of life persisting across an entire supercontinent. Step into the vast plains and dense forests of Pangea, and the scale of life is immediately humbling. This was not a world of small, cautious creatures alone. Here, some animals grew to unimaginable sizes, their forms both terrifying and awe-inspiring. Imagine walking beside an amphibian that stretches the length of a modern bus, its muscular legs propelling it silently through swamps, its eyes scanning the water for the slightest ripple that might betray prey. Life on Pangea is a constant interplay between titanic power and fragile vulnerability, a world where even the smallest misstep could invite instant danger. Giant reptiles dominate the landscape, their sheer size reshaping ecosystems. Predators like gorgonopsids, armed with long saber-like teeth, stalk the open plains with calculated patience, their muscles coiled like springs, ready to unleash lethal force. Meanwhile, colossal herbivorous synapsids graze in cautious herds, their massive frames acting as both shield and weapon. Every movement of these giants sends ripples across the terrain. Dust clouds swirl, smaller animals scatter, and even rivers can be redirected as enormous creatures trample over their banks. In swamps and river systems, massive amphibians rule the waters. Some, the size of modern crocodiles, patrol murky pools with slow, deliberate strokes, waiting to ambush prey. Their skin glistens in the dappled sunlight filtering through prehistoric ferns, and their presence dominates the sounds of the wetland. Frogs, salamander-like creatures, and small fish flit nervously among their legs, aware that the slightest movement could bring death. Life in these watery realms is brutal, beautiful, and endlessly fascinating. Flying creatures add another layer of intrigue to this world. Early pterosaurs glide across the skies, their membranous wings catching thermals rising from heated plains. With keen eyesight, they hunt fish in rivers or scavenge along the edges of predator kills. Imagine looking up from a forest floor and seeing a shadow pass overhead, a silent, efficient hunter navigating Pangea's vast expanse with effortless grace. Every animal, whether in water, on land, or in the sky, is part of a network of survival that spans the entire supercontinent. Even the smallest creatures contribute to the drama. Insects swarm across swamps, pollinating ferns and cycads, while tiny amphibians hide in leaf litter to avoid the giants above. Their survival is precarious, yet their presence is vital, supporting the food chains that sustain enormous predators. Life operates at every scale, from the microscopic to the colossal, creating a balance that is both fragile and remarkably resilient. Predatory strategy is breathtaking to observe. A gorgonopsid on the hunt studies the terrain, calculating every movement of prey. Its massive jaw opens with terrifying precision, capable of delivering a lethal bite in an instant. The prey responds with equal ingenuity. Herds scatter in coordinated patterns, some individuals feigning vulnerability to distract predators while others escape. These ancient dramas of life and death repeat countless times across Pangea, shaping evolution and behavior in ways we are only beginning to comprehend. Even in deserts and arid interiors, giant creatures have adapted extraordinary survival techniques. Some herbivorous synapsids developed thick, scaly hides to minimize water loss, while others traveled great distances between sparse watering holes. Predators in these regions evolved endurance and cunning, hunting not just for strength, but for intelligence and patience. Every interaction across the supercontinent is a calculated gamble, a high-stakes test of adaptation and resilience. The impact of these giants on the environment is immense. Forests bend under the weight of trampling herds. Rivers are reshaped by repeated crossings, and wetlands teem with life stirred into motion by massive feet. Every creature contributes to the sculpting of the landscape, shaping both the physical terrain and the ecosystems that depend on it. Life and land are intertwined in a perpetual, breathtaking cycle. At night, the supercontinent transforms. Shadows grow long across plains and forests, nocturnal predators emerge, and even the giants adapt to darkness. Amphibians call from pools, insects hum in the undergrowth, and massive reptiles patrol silently, their senses heightened in the dim moonlight. The nocturnal rhythm of Pangea is a world of whispers, rustling leaves, and the soft thud of enormous steps echoing through forests and swamps alike. Across the breadth of Pangea, giants define the rhythm of life. From colossal amphibians gliding through swamps to massive herbivores grazing under the sun, and from cunning predators stalking the plains to aerial hunters gliding across the skies, every creature is part of an intricate, interdependent world. Survival is constant, adaptation is necessary, and life in the age of Pangea is as thrilling, terrifying, and mesmerizing as anything imagined in our wildest dreams. As we turn our gaze from the immense landmass of Pangea to the vast waters surrounding it, a whole new world of motion, life, and mystery unfolds. The oceans were not calm or tame. They were immense engines of energy, sculpting coastlines, shaping climates, and nurturing life in ways that ripple across time. Imagine the edges of Pangea's coastline, where warm, shallow seas meet land, and tidal currents sweep in rhythmic, unstoppable waves. The water is alive, glistening under the sun, carrying with it the promise of sustenance, danger, and discovery. Shallow seas near coastal regions teem with life. Coral-like structures, though primitive compared to today's reefs, form vibrant underwater forests. These reefs are bustling cities for countless creatures. Small fish dart through coral branches, trilobites scuttle along the seafloor, and cephalopods glide with fluid grace, hunting and evading predators alike. Each movement is part of a delicate, intertwined system, where every ripple or shadow can alter the course of a life in an instant. Beyond the shallow waters, deeper oceans conceal giants of their own. Enormous fish patrol open waters, moving in slow, deliberate patterns that hint at both grace and danger. Early sharks, sleek and predatory, cut through the currents with precision, their senses finely tuned to vibrations and chemical cues in the water. Imagine being a small fish in these depths, every flick of a fin or swirl of water potentially heralding a predator's attack, and every moment a test of agility, instinct, and luck. Currents around Pangea are shaped by the immense size and positioning of the supercontinent. Warm equatorial waters clash with cold polar currents, creating massive whirlpools, eddies, and upwellings of nutrients that feed life both near the surface and in the depths. Imagine plankton-rich waters surging upward, attracting schools of small fish, which in turn draw predatory fish, amphibians, and even early marine reptiles, all locked into a cycle that sustains ecosystems across hundreds of kilometers. The ocean is a living conveyor belt of energy and survival. Coastal wetlands act as crucial nurseries for marine life. Shallow lagoons and estuaries provide shelter for juvenile fish, amphibians, and invertebrates. Tiny creatures hide among the reeds and algae, learning to navigate a world where every shadow might conceal a hunter. Meanwhile, their parents patrol the waters nearby, feeding, reproducing, and moving with the tide. This dynamic interplay between shelter and exposure, predator and prey, defines the rhythm of life along Pangea's shores. Even in the open ocean, survival is a constant challenge. Large marine reptiles, some as long as buses, patrol the waters with stealth and power. Their flippers cut through waves silently, their eyes scanning for movement below or above. Schools of fish dart and swirl in mesmerizing patterns, coordinating instinctively to avoid predation. Imagine witnessing a predator's strike. Water erupts in a violent splash, fish scatter, and the hunter disappears as quickly as it appeared, leaving ripples that slowly fade across the surface. The ocean currents themselves influence life in dramatic ways. Strong winds funneling across Pangea drive upwellings and create temporary nutrient-rich zones. Hurricanes and tropical storms churn the surface, uprooting plants, tossing fish, and creating opportunities for opportunistic predators. Yet even disaster brings life. Decomposed matter sinks, feeding creatures in deeper waters, while new niches are created as habitats shift. Life adapts constantly, evolving strategies to exploit every change, every surge, every pulse of the ocean. On the seafloor, a hidden drama unfolds. Ammonites spiral through the water in hypnotic patterns, feeding and evading. Crustaceans scuttle across soft sediment, sensing vibrations above. Small predators hunt with calculated precision, while larger marine reptiles navigate carefully to avoid injury or confrontation. Each layer of the ocean, from sunlit surface to shadowed depths, hosts a world of tension, survival, and extraordinary adaptation. Even along icy coasts near Pangea's polar regions, life persists. Cold, nutrient-rich waters bring an abundance of plankton, feeding schools of fish that migrate vast distances. Amphibious reptiles hunt along frozen edges, while the tides sculpt intricate ice patterns that create microhabitats. Life thrives in niches previously unimagined, showing resilience and ingenuity at every scale. The oceans of Pangea are alive, dynamic, and mesmerizing. Currents, tides, storms, and coastal interactions create a living, breathing environment where life evolves, survives, and flourishes. From the smallest plankton to enormous marine reptiles, each organism is part of a vast, interconnected system that spans the supercontinent's watery edges. The ocean is not just a backdrop, it is a world of movement, mystery, and the raw power of life in motion. As we traverse the immense landscapes of Pangea, one cannot ignore the raw power of the land itself. Mountains rise like jagged crowns across the supercontinent, their peaks slicing into the sky, carved by tectonic collisions and relentless natural forces. Imagine standing at the base of a rising ridge, feeling the tremors beneath your feet, listening to the wind whistle through newly formed valleys. These mountains are not just scenery. They are titanic forces sculpting climate, rivers, and ecosystems. Volcanoes punctuate the horizon, some already dormant, others spewing fire and smoke, reshaping everything around them. Lava flows cascade over plains and forests, leaving paths of destruction but also fertility in their wake. Minerals and nutrients from volcanic eruptions enrich soils, allowing forests to flourish in areas previously barren. Picture a giant eruption, ash clouds billowing high into the atmosphere, sunlight dimmed across vast regions, while creatures of all sizes scramble for survival. Life persists around these fiery giants, adapting to sudden, dramatic changes with astonishing ingenuity. Tectonic activity is the heartbeat of Pangea. The massive supercontinent is still moving. Plates grinding, colliding, and pulling apart, creating earthquakes that ripple through plains and valleys. Rivers shift course, mountains uplift, and valleys deepen, constantly redefining the living spaces of countless species. Imagine the ground trembling beneath your feet as a synapsed herd flees a sudden quake. Predators navigating the chaos with instinctive precision. Every tremor tells a story of a world in flux, where survival depends on awareness, agility, and sometimes pure luck. The impact of mountains on climate is profound. Wind patterns bend and swirl around towering peaks, creating rain shadows on one side and lush forests on the other. Snow accumulates at higher altitudes, feeding rivers that carve deep gorges over millennia. Life adapts to these conditions with remarkable creativity. Plants cling to cliff faces, reptiles bask in the sun on rocky slopes, and amphibians navigate temporary streams formed by melting snow. Each peak, ridge, and valley is a theater where geological drama and biological adaptation intertwine. Volcanic activity also shapes the oceans that border Pangea. Lava entering the sea generates steam, temporary islands, and shifts in marine habitats. Coastal ecosystems evolve to exploit these changes, with fish, amphibians, and invertebrates taking advantage of newly formed shallow waters, or nutrient-rich deposits. Imagine the subtle choreography of life responding to volcanic pulses, creatures adjusting feeding and breeding patterns to the rhythm of an ever-changing environment. Even in deserts far from tectonic upheaval, the presence of distant mountains influences life. Winds funnel through passes, creating sudden gusts that shift sand dunes, disperse seeds, and challenge the endurance of migrating herds. Temperatures fluctuate dramatically, from scorching day heat to icy nights, and plants and animals have evolved extraordinary adaptations to survive in these extremes. From the tiniest insect burrowing beneath sand, to massive herbivores pacing cautiously along ancient trails, life in these regions is a masterclass in resilience. Lava flows and volcanic ash clouds leave permanent marks on the supercontinent. Thick layers of volcanic rock create new landscapes, while mineral-rich soils allow pioneering plants to take root. Forests spring up in unexpected places. Amphibians colonize newly formed wetlands, and reptiles roam fresh plains, exploiting resources that never existed before. This cycle of destruction and creation is relentless, illustrating that the geology of Pangea is not passive, but actively shaping the destiny of every living organism. Mountains also serve as migration routes and barriers. Rivers cut deep valleys that guide the movement of herbivores, predators, and even early insect swarms. Steep cliffs force adaptations in climbing and leaping, while isolated peaks allow unique ecosystems to develop, almost like islands in the sky. Imagine a herd of massive synapsids navigating a narrow mountain pass, balancing between safety and exposure, while predators lurk in shadowed cliffs, waiting for the perfect moment to strike. Even underground, life is influenced by geological drama. Subterranean rivers carve tunnels and caves, creating microhabitats for amphibians, insects, and smaller reptiles. Volcanic vents release heat, sustaining ecosystems in otherwise frozen or dry regions. Imagine tiny creatures thriving in these hidden refuges, completely shielded from the chaos above, yet intimately connected to the tectonic heartbeat of the supercontinent. Pangea's mountains and volcanoes are not mere backdrops. They are central actors in an epic, ongoing performance of life and death, creation and destruction. Each peak, valley, eruption, and tremor drives evolution, dictates survival strategies, and transforms landscapes in ways both subtle and catastrophic. The land itself is alive, restless, and endlessly fascinating, offering a stage where life must constantly adapt or vanish. Imagine standing on the bank of one of Pangea's colossal rivers, its waters stretching farther than the eye can see, winding through forests, plains, and deserts alike. These rivers are the arteries of the supercontinent, carrying not only water but life itself. Fish and amphibians glide in the currents, small reptiles dart along the muddy edges, and countless insects hover over the surface, each organism relying on these waterways for sustenance, movement, and survival. The rivers pulse with energy, shaping the landscape as they carve valleys, deposit nutrient-rich silt, and connect distant ecosystems in ways both visible and hidden. Lakes and inland seas offer pockets of tranquility amid the vastness, yet their calm is deceptive. Seasonal flooding can transform a placid lake into a roaring torrent, forcing creatures to adapt quickly or perish. Imagine herds of synapsids cautiously approaching the water to drink, their senses alert for predators lurking nearby. Meanwhile, fish and amphibians thrive beneath the surface, navigating complex underwater terrain, hiding among plant roots and evading aquatic predators. The lakes serve as microcosms of life, intense and teeming, every moment a delicate balance between survival and predation. The formation of rivers is closely tied to Pangea's mountains and tectonic activity. Snowmelt from towering peaks feeds streams that converge into vast river systems, carrying minerals and organic matter across hundreds of kilometers. These rivers act as highways for migration, offering food, water, and passage for herbivores, predators, and even insects. Imagine following a migrating herd along a river valley, hearing the distant calls of predators, sensing the rustle of smaller creatures, and feeling the life of the supercontinent vibrating through the soil and water. Coastal estuaries form rich transitional zones between land and sea. Brackish waters teem with life, where saltwater fish mingle with freshwater species, creating biodiversity hotspots. Amphibians, reptiles, and early fish species exploit these unique environments, finding shelter among reeds, mangrove-like plants, and shallow lagoons. Every splash of a tail, every ripple in the water signals movement and life. These estuaries are dynamic ecosystems, their productivity rivaling the forests, yet shaped by tides, storms, and the constant interplay of freshwater and saltwater currents. Waterfalls and rapids add drama to the landscape. Rivers cascading over cliffs form miniature storms of mist and thunder, creating habitats for specialized creatures. Fish adapted to strong currents leap upstream to spawn, while reptiles navigate rocky banks with cautious precision. Birds or flying reptiles might circle above, scouting for prey, while amphibians cling to damp rocks, camouflaged against predators. The movement of water creates microhabitats in constant flux, a natural theater of opportunity and risk. Floodplains, where rivers occasionally spill over their banks, are vital for life. Nutrient-rich silt rejuvenates soils, enabling plants to flourish, which in turn feeds herbivores that graze on the lush vegetation. Predators follow these seasonal migrations, timing their hunts with precision. Imagine the rhythm of these plains. Mud squelching underfoot, herds moving in waves, predators stalking silently, and smaller creatures darting for cover. Life is orchestrated by the water itself, a pulse felt across ecosystems both near and far. Underground waterways and subterranean rivers add another layer of intrigue. These hidden channels sustain ecosystems invisible from above, hosting amphibians, insects, and even early reptiles in a constant cycle of survival. Stalactites drip from ancient caves, and the sound of underground streams echoes through dark chambers, creating secretive sanctuaries for life away from the chaos of the surface. Even here, survival is an intricate dance. Prey avoiding predators, small fish navigating currents, and amphibians exploiting niches unknown to larger creatures. Seasonal changes dramatically alter rivers and lakes. During rainy periods, waterways swell, connecting previously isolated lakes and wetlands, allowing species to disperse and interact. In dry seasons, water levels recede, concentrating creatures into smaller habitats, increasing competition and risk. Imagine amphibians leaping from shrinking pools, reptiles patrolling exposed shores, and fish maneuvering through narrowing channels, all adapting in real time to the changing water landscape. Glacial melt during certain periods contributes to rivers, adding icy currents that challenge life with frigid temperatures. Creatures must adjust to sudden changes, seeking refuge in calmer pools or burrowing into sediment to survive. The combination of ice, flowing water, and fluctuating temperatures creates an environment that is dynamic, perilous, and endlessly fascinating, shaping adaptations in ways both subtle and dramatic. Rivers, lakes, and waterways are the lifeblood of Pangea. They connect distant regions, sustain entire ecosystems, and create both opportunities and hazards for every creature. From the smallest amphibian hiding among reeds to the largest herbivore approaching the bank to drink, every being interacts with water in ways that define survival, migration, and behavior. Life is inextricably tied to these watery veins of the supercontinent, a constant rhythm of movement, energy, and adaptation. Captivating and immersive, a story of life sculpted by water itself. As we traverse the massive supercontinent of Pangea, the climate itself becomes a character in this unfolding story. Stretching across nearly every latitude, Pangea hosts an astonishing variety of environments. The equatorial regions are sweltering and humid, teeming with lush vegetation, enormous rivers, and dense forests. Imagine the sticky air clinging to your skin, the sun beating down through a thick green canopy, while the calls of countless creatures echo from treetops to riverbanks. This is a world of abundance, where life thrives in heat, humidity, and relentless energy. Moving away from the equator, deserts emerge like oceans of sand and stone. Interior regions of Pangea experience extreme heat during the day and icy cold at night. The landscape is harsh, yet life is endlessly inventive. Plants conserve water with tough, waxy leaves, while small reptiles and insects burrow into the earth to escape the sun's relentless gaze. Herbivorous synapsids and other creatures must travel great distances between water sources, their survival depending on memory, endurance, and careful timing. Imagine the shimmer of mirages, the crunch of sand underfoot, and predators lurking in the sparse shadows, all part of the delicate dance of desert life. In tropical zones, forests and wetlands flourish with unprecedented diversity. Towering ferns, cycads, and primitive conifers form labyrinthine jungles. Rivers snake through the terrain, feeding wetlands where amphibians and early reptiles flourish. Imagine walking through this tropical maze, leaves dripping with condensation, insects buzzing in hypnotic patterns, and every movement above or below the soil potentially signaling predator or prey. The tropics are a riot of color, sound, and life, every square meter vibrating with biological energy. Polar regions of Pangea are equally dramatic, though cold, icy, and often extreme. These areas experience long periods of darkness followed by extended daylight, challenging every living creature to adapt. Mosses, lichens, and hardy shrubs cling to rocky ground, while amphibians and early reptiles seek shelter in microhabitats that protect them from freezing temperatures. Imagine the subtle illumination of polar twilight, ice glistening under faint sunrays, and creatures navigating a frozen, hostile world with remarkable ingenuity. Survival in these regions is not just about strength. It's about strategy, timing, and an intimate understanding of a climate that changes dramatically with the seasons. Monsoons and seasonal rains dramatically shape Pangea's landscapes. In tropical regions, sudden downpours swell rivers, floodplains, and create temporary wetlands, providing abundant food but also hazards. Herbivores must adapt to rapidly shifting landscapes, while predators exploit the chaos with calculated precision. Imagine the smell of wet earth, the sound of water rushing through forests, and the frantic movements of animals navigating the sudden torrent. Every moment alive with tension, opportunity, and the constant interplay of life and environment. Wind patterns sculpt deserts and mountains alike. Hot, dry winds sweep across arid regions, shifting sand dunes and dispersing seeds across hundreds of kilometers. Cold winds descend from mountains or polar zones, chilling forests and wetlands, forcing creatures to seek shelter or adjust behaviors. The climate dictates movement, feeding, reproduction, and survival strategies, creating an invisible rhythm that pulses through every ecosystem. Life is constantly listening, responding, and adapting to the ever-changing breath of the supercontinent. Volcanic activity also influences climate zones. Ash clouds and gases can temporarily cool the atmosphere, creating microclimates far from eruption sites. Fertile soils form in volcanic regions, encouraging dense vegetation and attracting herbivores, which in turn draw predators. The interplay of fire, stone, and weather demonstrates that climate on Pangea is a dynamic force. shaping ecosystems and survival in intricate, often unpredictable ways. Rivers, lakes, and mountains interact with climate to create unique microhabitats. High-altitude valleys might support temperate forests, even as lowland deserts bake in sun and heat. Coastal plains may flood seasonally, sustaining wetlands and tidal ecosystems. Life adapts in ingenious ways. Reptiles bask on warm rocks, amphibians find refuge in shaded pools, and insects exploit every niche available. The climate is not just a backdrop. It's an active participant in the drama of survival and evolution. Even small shifts in climate can trigger massive changes in ecosystems. A dry season might reduce river levels, concentrating fish and amphibians into shrinking pools, which in turn affects predator behavior. A wet season might flood forests, forcing herds to migrate, reshaping vegetation, and redistributing nutrients. Every fluctuation is felt across scales, from microscopic insects to towering reptiles, a continuous ripple of cause and effect that drives life forward in unpredictable ways. Life on Pangea is inseparable from climate. From the torrid tropics to arid deserts, from icy poles to monsoon-soaked forests, the supercontinent presents challenges and opportunities in every corner. Each creature, plant, and ecosystem responds with adaptations honed over millions of years, creating a world that is mesmerizing, dynamic, and endlessly captivating. The climate is not merely a setting. It is an omnipresent force, guiding, shaping, and sometimes challenging life in ways that are as thrilling as they are beautiful. While the towering reptiles and massive amphibians of Pangea often dominate our imagination, it is the smaller creatures, the insects, arachnids, and tiny reptiles that form the intricate web of life upon which the supercontinent depends. Step carefully through a fern-filled forest floor, and you enter a hidden kingdom buzzing with activity. Every leaf, every stalk, every patch of soil is alive with movement, color, and sound. Antennae flick, wings shimmer, legs scuttle, and survival strategies unfold in ways both subtle and extraordinary. Insects in Pangea are astonishingly diverse. Early beetles navigate the dense undergrowth, their hard exoskeletons protecting them from predators, while their mandibles slice through plant matter with precise efficiency. Dragonfly ancestors skim over wetlands, their elongated bodies cutting through the humid air as they hunt smaller insects. Crickets, grasshoppers, and cockroach-like species hop, jump, and scuttle in chaotic rhythms that are orchestrated by instinct honed over millions of years. Each movement is purposeful, a calculated dance of evasion, hunting, or mating. Arachnids patrol shadows and soil, masters of patience and cunning. Spiders spin silken webs that glint in dappled sunlight, perfectly camouflaged among ferns and cycads, capturing unsuspecting prey. Scorpions and small predatory arachnids navigate leaf litter and rocky crevices, their venom and speed allowing them to dominate microhabitats with stealth and precision. The drama of predator and prey unfolds at a scale that is almost invisible, but intensely real, tiny worlds echoing the same tension and strategy as the massive ecosystems above. Amphibians and small reptiles thrive in the humid corners of Pangea. Salamander-like creatures and early lizards dart between damp logs and shallow pools, avoiding larger predators while hunting insects. Their skin glistens with moisture, absorbing nutrients and warmth from the environment, while their keen senses detect vibrations and chemical cues, signaling danger. Life for these creatures is an intricate game of awareness, reflexes, and survival instincts, played across a stage of ferns, moss, and mud. Even fungi and microscopic organisms play a pivotal role. Decomposing plant matter becomes a hidden banquet for insects, worms, and small amphibians, while fungi recycle nutrients into soil, supporting new plant growth. Without these often overlooked participants, the towering giants and sprawling forests of Pangea could not exist in harmony. The smallest players sustain the largest. A delicate balance maintained through unseen collaboration and competition. In wetlands and riverbanks, insects dominate the air and water alike. Mosquito-like insects hover above stagnant pools. Dragonfly ancestors dive through reeds, and aquatic larvae navigate underwater worlds with remarkable efficiency. Birds are not yet present to prey on them, so these insects explore, reproduce, and hunt with near-total autonomy, shaping the food web that will eventually support larger predators. Even the tiniest twitch of a leaf or ripple in water signals life, death, and survival in this miniature but fiercely competitive ecosystem. Burrowing creatures add another layer of complexity. Early worms, small amphibians, and lizard-like animals tunnel through soil, shaping it as they go. These burrows protect them from predators, conserve moisture, and create habitats for other small creatures. Imagine peering into a network of hidden tunnels, a shadowy maze where tiny lives intersect in ways invisible to the naked eye, yet crucial for the survival of larger ecosystems. Predation, defense, and reproduction drive constant innovation. Some insects evolve camouflage that mirrors leaf shapes, bark textures, or moss patterns. Others develop speed, armor, or venom to survive encounters with predators. Arachnids refine web-building techniques to capture elusive prey, while small amphibians use stealth, mimicry, and rapid movement to outwit danger. Every day is a high-stakes challenge. Each interaction a lesson in survival honed over millions of years. Even seasonal changes shape these miniature worlds. Wet seasons flood burrows and inundate lowlands, forcing creatures to relocate or adapt. Dry seasons parch soil and shrink pools, concentrating prey and predators alike, escalating competition. Microhabitats shift in response, and only those with flexibility, cunning, or extraordinary adaptation thrive. Life is in constant motion, a whispering, scuttling, crawling symphony beneath the feet of giants. Insects, arachnids, and small reptiles are the unsung architects of Pangea's ecosystems. Their lives may be tiny, but their impact is monumental, sustaining food chains, shaping habitats, and driving evolutionary innovation. In the hidden corners of forests, wetlands, and deserts, they engage in endless dramas of survival, ingenuity, and adaptation. Watching these miniature worlds unfold, one cannot help but marvel at the intricate, mesmerizing complexity of life on a supercontinent where every scale, from the microscopic to the colossal, is alive with purpose, struggle, and wonder. As we step deeper into the heart of Pangea, the landscape transforms under the touch of ancient flora. Forests stretch as far as the eye can see, a dense tapestry of green that blankets valleys, slopes, and riverbanks. Towering ferns sway in the humid breeze, their fronds catching light in intricate patterns, while cycads and primitive conifers punctuate the greenery with stiff, architectural elegance. Each plant is a survivor in a world constantly shaped by shifting climates, volcanic eruptions, and the relentless march of time. The undergrowth is alive with subtle motion. Mosses cling to rocks and fallen logs, providing moisture and shelter for insects, amphibians, and small reptiles. Delicate spores drift silently on the wind, promising new life in far-off corners of the supercontinent. Imagine the soft, rhythmic rustle of leaves underfoot, the faint scent of wet soil, and the tiny dramas of life unfolding invisibly among roots and stems. Every corner of this lush, green world pulses with vitality and hidden intrigue. Forests vary dramatically across Pangea's immense span. Near the equator, tropical forests are dense, humid, and buzzing with life. Sunlight filters through multiple layers of canopy, creating a patchwork of shadows and warmth on the forest floor. Each ray of light illuminates creatures and plants, highlighting intricate details. The spiral of a fern frond, the sheen of a primitive insect's wing, the slick surface of a moisture-loving amphibian. Life here is abundant and fiercely competitive, every organism adapting to occupy its niche with precision. In contrast, in higher latitudes and drier interiors, plant life adapts to harsher conditions. Conifers dominate slopes and plains, their needle-like leaves conserving water and resisting cold. Ferns cluster in shaded gullies and near waterways, taking advantage of any moisture that persists. Sparse deserts punctuate the heart of Pangea, where hardy shrubs, drought-resistant ferns, and stunted trees cling to survival with astonishing resilience. The interplay of plant life and environment is a constant negotiation between abundance and scarcity, growth and limitation. Rivers, lakes, and wetlands provide lifelines for the flora, nourishing forests and creating vibrant ecosystems. Floodplains host periodic bursts of growth, as nutrient-rich silt is deposited across the land. Imagine witnessing a forest floor springing to life after a seasonal flood. New shoots pushing through the soil, insects and small reptiles emerging to explore the transformed landscape, and predators adjusting their movements to match the pulse of renewed vegetation. Water is life, and the plants of Pangea are exquisitely attuned to its rhythms. Volcanic regions leave their mark on plant life as well. Lava flows and ash deposits initially devastate forests, but over time, these areas become fertile grounds for pioneering plants. Ferns are often the first to recolonize ash-covered plains, followed by cycads and early conifers. Life adapts to the rhythm of destruction and renewal, illustrating the resilience and persistence of flora in a world constantly in flux. The interplay of fire, stone, and green growth shapes the landscapes in ways both dramatic and subtle. Even small adaptations in plants have profound consequences. Leaf structures, spore dispersal methods, and growth patterns dictate survival in particular environments. Ferns may grow taller in shaded regions to capture sunlight, while conifers invest energy in deep roots to access hidden water. Mosses and ground covers retain moisture, offering microhabitats for insects and amphibians. Every detail, from leaf texture to root depth, plays a role in survival, reproduction, and the interconnected web of life. Forests are also theaters of competition and cooperation. Plants compete for sunlight, water, and space, yet they also support each other indirectly by stabilizing soil, moderating microclimates, and creating habitats for other organisms. Imagine the intricate balance of shade and light, moisture and dryness, decay and growth, all orchestrated across thousands of square kilometers of forest. Each tree, fern, and shrub is both a competitor and an essential component of a larger ecological symphony. The seasonal cycle of Pangea further animates plant life. Dry seasons challenge survival, prompting dormancy, reduced growth, and strategic reproduction. Wet seasons bring explosive growth, with new leaves unfurling, spores releasing into the wind, and waterways swelling with nutrient-rich water. Plants respond dynamically, their life cycles intimately intertwined with the rhythms of climate, ensuring that each year brings both opportunity and challenge. Primitive plants of Pangea are more than scenery. They are architects of the supercontinent's ecosystems. From towering forests to hidden mossy corners, they provide structure, shelter, and sustenance. Their growth and survival dictate the movement and behavior of countless creatures, influence climate and soil conditions, and set the stage for the complex interactions of life that echo across every habitat. The forests, ferns, and conifers of Pangea are a living testament to resilience, adaptation, and the quiet yet profound drama of life, thriving in a world shaped by time, stone, and relentless environmental forces. Imagine standing on the endless plains of Pangea. The land stretches farther than the eye can see, a single colossal continent with no familiar oceans to break its immensity. But what would truly disturb you? What would make you unable to sleep after picturing it? is not just the ground beneath your feet. It's the sky above. Because the sky of Pangea was unlike anything we know today. The horizon wasn't always blue and comforting. Sometimes it was stained red with iron-rich dust storms that blew across the continent like ghosts of a dying world. Imagine watching the sun dip behind the jagged ridges of mountains formed when continents smashed together, only to see the sky blaze into a blood-colored inferno. The air thick with dust so fine you could taste it on your tongue. And when night came, there were no city lights, no interruptions, no human-made glow to dim the stars. Instead, the Milky Way cut across the heavens in a river of fire, 1,000 times brighter than what you see now. Entire galaxies would have been visible, painted across the cosmic canvas, so clear they almost felt close enough to touch. But this beautiful, endless sky could turn hostile in an instant. The storms of Pangea weren't just storms, they were apocalyptic events. With fewer oceans to moderate the climate, temperature differences were extreme. Picture standing in the middle of the supercontinent, hundreds of miles from any sea. The heat of the day would rise until the land cracked, split, and baked like ceramic. Then, suddenly, a colossal storm system could form, churning with lightning so powerful it seemed to slice the heavens apart. The lightning of Pangea was rumored to have been stronger, sharper, more destructive than modern bolts, an electric orchestra echoing over a barren plain, where the wind howled like a predator searching for prey. And what about the rain? When it came, it didn't fall in pleasant droplets. It came as walls of water, roaring across the land, smashing down gullies, carving rivers in days that would take centuries today. Then it would vanish again, leaving cracked deserts behind, scars on the earth like wounds that refused to heal. But perhaps the most haunting part of Pangea's sky was what it carried. The very breath of extinction. Volcanic eruptions in what is now Siberia released so much ash and gas into the atmosphere that the skies sometimes turned a choking grey. Imagine looking up and seeing not a welcoming sun, but a dull orange orb dimmed through curtains of smoke. The air would be thick, acrid, heavy. Breathing would be labor, every lungful reminding you that this was a world where survival was fragile. Acid rain would fall, corroding plants, poisoning lakes, leaving behind a landscape that felt cursed. Now, consider the creatures that lived under this sky. Massive reptiles, towering plants, and early ancestors of mammals. They didn't just live on the land. They adapted to a sky that could betray them at any moment. Some creatures may have hunted by moonlight so bright it made the world glow silver, their eyes reflecting the brilliance of a night sky we can only imagine now. Others may have hidden in burrows when storms broke, knowing the crack of thunder could shatter the silence for miles, driving prey and predator alike into frenzy. But here's something even more unsettling. Astronomers and geologists suggest that Earth's tilt during Pangea may have shifted in ways we barely comprehend. Imagine the poles and equator bathed in extremes, with seasons so violent they made survival a cruel lottery. You might see ice and snow where today there is desert, and burning heat in regions we now know as frozen wastelands. The sky itself was a canvas of chaos, and above Pangea, it told stories of creation, destruction, and rebirth. If only one could understand its language. Think of this. If you stood on Pangea and looked up, the constellations themselves would look different. The stars haven't moved much in 250 million years, but your position on one giant landmass, not scattered continents, would shift the way you perceive the heavens. Did the creatures of Pangea, in their primitive ways, sense the rhythm of the stars? Did they know that the sky above was not eternal, that this land, this supercontinent, would one day split apart and scatter across the globe? The sky of Pangea wasn't just atmosphere. It was a stage for violence, for beauty, for terror. It was the last thing countless creatures saw before they vanished forever, consumed by extinction, buried beneath shifting continents. And it's the one thing we cannot truly bring back. We can simulate the land, reconstruct the fossils, map the climate, but we can never again stand beneath the alien, terrifying and breathtaking sky of Pangea. The air over Pangea was not still. It was alive, turbulent, a shifting battlefield between burning heat and crushing cold. To live during this time was to live beneath skies that could change in an instant. Imagine standing on a vast, endless plain in the center of the continent. The horizon stretches so far you can barely sense its curve. The sun blazes down from above, merciless, no moisture in the air to shield you. For weeks, maybe months, you see not a single cloud. Plants wilt. Rivers retreat into cracked beds of stone. Dust devils snake across the land like whips of fire. The land groans under the weight of drought. Then it happens. A deep roar from the horizon. A shifting line of darkness growing ever larger. Storm clouds. But not the gentle, rain-bringing clouds, you know. These were monsters of the sky. The sheer heat trapped inside Pangea's interior fed them, transforming ordinary storms into leviathans. Walls of black thunderheads rose like mountain ranges in the sky. Forks of lightning slashed from one end of the heavens to the other, arcing for miles. The sound? Deafening. Each strike cracked like the snapping of the earth's own bones. The winds whipped into cyclones. Tornadoes not the size of towns, but the size of cities. They were so vast that entire forests were ripped from the ground. Their trunks hurled across the land like spears. And when the rain fell, it did not fall softly. It crashed. Torrents pounded the ground until the baked soil turned to rivers of mud. Flash floods swept away everything in their path, gouging canyons, reshaping valleys. But here's the thing, these storms were not random. They were the heartbeat of Pangea. The supercontinent itself created them. With one vast landmass, heat could not be evenly distributed. The center baked like an oven, while the edges along the seas felt constant moisture. This imbalance was fuel, an engine that birthed megastorms again and again. If you lived in Pangea, you did not ask if a storm would come. You asked when. Now imagine you are one of the animals. A towering sauropod, its neck stretching above the trees, trying to sniff the air for warning. The winds shift, carrying scents of ozone and petrichor, that unmistakable smell before a downpour. The herds grow restless. Massive creatures thunder toward higher ground, their heavy feet pounding the earth in unison. Smaller reptiles scatter into burrows, hoping to survive the onslaught. Overhead, pterosaurs, those winged masters of the sky, struggle against gusts that tear at their wings. Some are thrown down, dashed against rocks, while others soar into the storm itself, gliding on currents of chaos. And still the storm grows. Lightning ignites forests, flames devouring miles of vegetation before the rain comes crashing down to smother them. It was a cycle of fire and water, destruction and renewal, life and death. Each storm reshaped the land, forcing species to adapt or perish. Entire ecosystems evolved under this pressure. To survive Pangea was to survive its storms. But the storms were not just natural phenomena, they were omens. Imagine ancient eyes, watching the skies, interpreting each roar of thunder as the voice of the earth itself. Creatures moved instinctively. But if a human-like intelligence had lived during this time, it might have seen these tempests as divine. The sky itself was alive, a living, breathing monster that judged the land below. And these storms were not confined to the land. Along the coasts of Pangea, hurricanes churned with a fury unlike anything modern Earth knows. With warm waters stretching for thousands of miles, these cyclones fed and fed until their winds reached unimaginable speeds. Waves the size of buildings slammed into the shores, carving cliffs, drowning plains, scattering marine life. Imagine standing on the edge of Pangea, staring at an endless heaving wall of water, knowing it could sweep the land for miles inland. The storms of Pangea were not nuisances. They were architects. They shaped rivers, carved mountains, distributed nutrients, and dictated the migrations of colossal beasts. Every raindrop, every lightning strike, every thunderous gust of wind played its part in writing the history of the supercontinent. And in this chaos, life thrived. Because the storms, as terrifying as they were, also gave something priceless: renewal. Ashes of burned forests fertilized the soil. Floods carried nutrients to barren lands. The aftermath of every storm was a rebirth. Pangea's storms were not merely destroyers, they were creators. Now, picture yourself standing there once more, beneath that impossible sky. The storm is breaking overhead. The lightning is so bright it blinds you, searing afterimages into your eyes. The thunder is so loud it rattles the bones in your chest. The rain is a curtain of silver, relentless, drumming against your skin. Around you, creatures scatter. The air is electric, and the very ground quakes with nature's fury. This was Pangea, not calm, not forgiving, but alive in ways modern Earth can barely remember. Imagine standing on the jagged edge of what we now call central Pangea. The land beneath your feet trembles ever so slightly, not from footsteps or storms, but from the restless groaning of the earth itself. Beneath the crust, colossal reserves of molten rock press upward, waiting for a weak point, waiting for the chance to rip open the surface. The air is thick, humid, almost oppressive heavy with carbon dioxide and sulfur that would choke us today, but fueled jungles the size of continents back then. Above, the skies of Pangea were unlike anything we can picture. Clouds didn't just drift lazily at times, they boiled, rising as towering anvils over superheated landscapes. Red-orange sunsets bled across the horizon because of volcanic ash hanging in the upper atmosphere. Imagine the entire sky taking on strange hues: blood red, copper, even sickly green when sulfur mixed with the sun's dying light. Standing under this canopy must have been surreal, as though every day was tinged with the reminder that the earth was alive, unpredictable and dangerous. But what about the air itself? During Pangea, oxygen levels soared at times to nearly 35%, compared to today's 21%. That might not sound dramatic, but picture this. Every breath you take feels cleaner, sharper, richer. Fires burn hotter, brighter, and faster. Lightning storms ignited forests with terrifying ease. And this abundance of oxygen allowed some of Earth's most bizarre life forms to grow to enormous sizes. Insects, creatures that scuttle by your window today almost unnoticed, were giants then. Imagine dragonflies with wingspans the size of hawks swooping over steaming wetlands, their wings glistening like stained glass in the sunlight. Imagine millipedes stretching longer than a human body, curling like armored serpents through damp jungles. Now, picture the seas. They weren't calm blue stretches like we see in travel ads. They were often dark, murky, and rich in life. Coastal waters were brimming with ammonites, shelled predators spiraling through the shallows like alien spacecraft. Sharks of strange forms dominated, some with snouts like saws, others with teeth shaped into bizarre whorls, spiraling inward like drills. The oceans of Pangea were both a cradle of life and a graveyard, because oxygen depleted, dead zones spread across the water, suffocating creatures unlucky enough to stray there. If you were to stand on a cliff and look out over a Pangean sea, the water might shimmer strangely under the sunlight, greenish with algae blooms, streaked with oil-slick colors from volcanic minerals leaching into the shallows. And the storms. With one single supercontinent, weather systems had no barriers. Winds could sweep unbroken for thousands of miles, gathering power, becoming tempests that made modern hurricanes look modest. Imagine dust storms rolling across endless dry basins, cloaking the land in a choking haze that lasted weeks. Then, in other regions, deluges, rains that didn't fall for hours, but for months. Rivers swelled into inland seas. Jungles drowned. Then, without warning, the rains would stop, leaving cracked, sun-baked land behind. Pangea's climate was not gentle, it was a pendulum, swinging violently between extremes. But perhaps the most haunting part of Pangea's atmosphere was its sense of scale. Stand anywhere, and the horizon stretched on, interrupted not by oceans, but by land that connected what we now know as Africa, South America, North America, Asia, and Europe. Imagine walking across deserts so vast that they seemed endless, where sandstorms buried entire ecosystems, or trekking through forests so dense that sunlight barely pierced the canopy, each step echoing with the calls of creatures long extinct. The earth must have felt infinite, yet claustrophobic. So much land, so much life, but no escape from the constant reminder that the planet itself was in flux. And all the while, deep fissures in Pangea exhaled smoke and fire. Lava flooded landscapes, burning away entire forests and leaving behind blackened plains of glassy rock. Geysers spewed superheated water and minerals high into the air, hissing like dragons. These eruptions didn't just reshape land. They reshaped life. Each time the earth belched fire, it altered the atmosphere, shifting carbon dioxide, oxygen, and methane. For the creatures of Pangea, survival meant constant adaptation to a world that could change in the blink of a geological eye. Now imagine nighttime on Pangea. The air cools, the storms fade, and silence blankets the land. But the sky was alive. With no light pollution, the stars blazed with impossible clarity. Constellations stretched differently than today, unfamiliar yet hauntingly beautiful. Imagine lying beneath them, the Milky Way unfurling in a ribbon of brilliance, while the ground still smoulders faintly from the day's volcanic tantrums. Perhaps even auroras, caused by the solar winds colliding with Earth's magnetic field, danced across the skies, shimmering curtains of green and violet over primeval jungles and deserts alike. The creatures of Pangea lived under this constant reminder that they were part of something far greater, something cosmic. And as the earth breathed in and out, erupting, flooding, burning, regrowing, life thrived. Yet, in its thriving, it was always walking a razor's edge. Too much fire and jungles turned to deserts. Too much rain and deserts drowned. Too much carbon and entire ecosystems collapsed. For the creatures of Pangea, the earth was not a nurturing mother. It was a capricious, fiery god, unpredictable and immense. So picture it, standing in the middle of Pangea, the air richer, the storms stronger, the skies darker, the creatures stranger. A world that felt both alien and familiar. A world where the earth itself was alive in ways we can only imagine today. Close your eyes for a moment and imagine stepping outside on Pangea, not into a jungle, not into a desert, not into a forest, but into a sky that looked nothing like the one we know today. The air was heavier, laden with carbon dioxide levels far higher than what we breathe now. Breathing would have felt thick, almost syrupy, as if every inhale coated your lungs. The sky itself may not have been the calm pale blue we see now, but sometimes an eerie orange haze, tinted by the endless volcanic eruptions that rattled the landscape. Ash clouds could stretch across whole regions, casting strange shadows over lands thousands of miles away. Sunsets were not the warm glow we're familiar with. They were fiery streaks of crimson and violet, magnified by particles drifting in the atmosphere. Storms were colossal, Imagine lightning storms that could last days. The sky illuminated like a flickering lantern, while rain poured in sheets so heavy you couldn't see more than a few feet ahead. Hurricanes or the ancient equivalents were not restricted to oceans, because the supercontinent's weather systems behaved differently than ours. Wind currents circled Pangea in bizarre, unpredictable ways, whipping dust storms across dry regions and feeding titanic rain systems along coastal swamps. And then, above it all, the night sky. With less light pollution, the stars would have exploded with clarity, millions glittering overhead, so sharp they almost seemed within reach. The Milky Way would have been a blazing ribbon cutting across the heavens, dwarfing even the most spectacular night we could hope to see today. But imagine this. The constellations we take for granted didn't exist in the same form. The stars were there, yes, but because of the slow drift of Earth's axis and the positioning of the continents, the view of the cosmos would have been alien compared to what you and I see. To a creature on Pangea, the skies were a completely different storybook. But what if the skies themselves influenced life on Earth in ways we've never considered? For instance, those volcanic eruptions belching carbon dioxide would have supercharged the greenhouse effect, trapping heat and making vast stretches of the interior unbearably hot. The storms, fueled by this unstable atmosphere, may have shaped migrations of giant reptiles and early ancestors of mammals, forcing them to follow rains or flee floods. Seasonal cycles may not have been gentle, predictable patterns. Some scholars suggest that years could swing wildly long periods of scorching drought, followed by years of flooding rains, pushing life itself to the brink of adaptability. And consider this chilling thought. Enormous meteors and comets streaking across that alien sky. Unlike today, where continents are spread out and impacts are localized, a major strike during the time of Pangea would have sent shockwaves racing across the single, massive landmass, shaking the supercontinent in unison. The sound would have been like the Earth itself, groaning a roar that could be heard thousands of miles away. Imagine standing on the edge of a swampy forest and feeling the ground beneath you tremble as if the entire world were a drum. The air wasn't just heavy with gases and storms. It was alive with sound. Wind howled through endless plains, volcanic explosions cracked like thunder, and distant herds of giant reptiles bellowed as they migrated across open lands. At night, the air might have been filled with strange, haunting calls of nocturnal creatures' voices, unlike anything we know today, echoing under the vast, starlit dome of an alien sky. But here's the unnerving twist. The skies of Pangea may have carried something more than storms and fire. Some scientists propose that massive bursts of solar radiation, flares from the young, more active sun, could have penetrated the thinner protective layers of Earth's magnetic field. Imagine standing under a night sky where auroras weren't limited to the poles but danced across the entire supercontinent. Green, red, and purple lights rippling above deserts, jungles, and mountains alike, an endless celestial performance that might have terrified or entranced the creatures below. Would early life have been influenced by these shimmering cosmic displays? Could cycles of radiation, auroras, and storms have driven evolution, forcing species to adapt to constant environmental stress? And yet, despite the chaos, there were moments of breathtaking calm. Picture dawn on Pangea's eastern coast, the sun lifting above the horizon to reveal endless stretches of shoreline, waves breaking on rocks that hadn't yet split into continents. Birds had not yet claimed the skies as we know them, but strange feathered reptiles glided between cliffs, their shadows stretching across the glowing sands. The air was thick, the light refracted through haze, giving everything a golden, dreamlike shimmer. Every breath, every storm, every night sky on Pangea carried with it a reminder that Earth was not yet finished. It was an experiment in progress, a planet still shaping itself. And if you stood there, staring upward at that alien sky, you'd know in your bones that this world was both beautiful and terrifying, balanced on the edge of chaos. Imagine looking up at the sky during Pangea. It wasn't always the calm blue canopy we take for granted today. Instead, the skies were alive, chaotic, and sometimes terrifying. The air shimmered with volcanic ash, thick clouds of smoke from endless eruptions stretching across the horizon. Lightning storms crackled over blackened skies, flashes of electric fire tearing through the gloom. To live under this sky was to live under constant reminder that the earth was not stable, but alive, breathing and roaring. At certain times, the sky glowed red not from the setting sun, but from the rivers of lava flowing across fractured landscapes. Whole regions were cloaked in a twilight of ash, where the sun barely pierced through. Imagine giant shadows of enormous reptiles moving across a dim horizon, their outlines flickering against a blood-red sky. The atmosphere itself became a theater of dread and awe, shaping how creatures lived, hunted, and survived. But the sky also carried whispers of mystery. Massive storms swept inland from the oceans, dark clouds boiling over the supercontinent with unimaginable power. The winds howled through canyons and across endless plains, bending the forests of towering ferns and conifers until they snapped. Rain would not fall gently. It hammered the land with torrents, swelling rivers into raging monsters that carved through valleys overnight. And then came droughts. The same sky that drowned the land could also abandon it, leaving deserts to crack open and swallow life whole. Above it all, strange patterns of the stars watched silently. Pangea stretched across such vast distances that the constellations would have looked different depending on where you stood. Some regions cloaked in endless night, while others burned under relentless sun. Without cities, without light pollution, the heavens would have been a dazzling display of cosmic fire. Early life on Earth, though mindless, lived under a dome of brilliance, a reminder that the planet's story was just one piece of something far greater. The creatures of Pangea adapted to this merciless sky. Some developed tough hides and burrowing behaviors to escape the storms. Others became swift travelers, chasing seasons across the endless supercontinent. The sky shaped evolution, forcing life to either bend to its will or vanish forever. Imagine a predator chasing prey across the plains. Suddenly, the ground shakes with thunder as the heavens unleash their fury. The chase drowned in sheets of rain, lightning revealing every trembling silhouette. For these creatures, survival wasn't just about hunting or hiding. It was about enduring the moods of the sky itself. The very air was different. Oxygen levels fluctuated, sometimes higher than today, fueling insects of impossible-sized dragonflies with wingspans longer than your arm, their shadows darting across the glowing red haze of volcanic twilight. Each breath carried the scent of ash, wet soil, or sulfur drifting from mountains that belched fire. To exist in Pangea was to exist under a sky that could bless you with life or smother you in death without warning. And yet there was beauty. Imagine standing on the edge of a massive inland sea as the storm clouds broke apart, revealing an otherworldly sunset, the skies streaked with purple, gold, and burning orange, the reflection shimmering across waters untouched by humankind. The silence after a storm must have been haunting, broken only by the distant calls of creatures we can only imagine. The sky of Pangea wasn't just weather, it was a constant reminder that Earth itself was the ultimate predator and creator, deciding which species thrived and which became dust. The Earth beneath Pangea was restless. For tens of millions of years, the colossal supercontinent held together, a massive jigsaw of crust welded by unimaginable forces. But deep below, where the mantle churned in slow, fiery currents, pressure was building. It was only a matter of time before the land began to tear itself apart. Imagine standing on the edge of an ancient desert in central Pangea. perhaps near where the modern-day Atlantic Ocean would one day open. The ground begins to tremble not from an earthquake, but from something more insidious, something slower. Massive cracks spread across the surface, rifts that stretched for hundreds of kilometers. Lava seeps upward, glowing rivers of molten rock painting streaks of fire across the barren land. This was not sudden devastation, but a drawn-out unraveling of the world as it was known. Geologists today can trace the scars of Pangea's breakup, etched into the rocks that lie beneath our feet. In Africa's Red Sea Rift, in the deep basins beneath the Atlantic Ocean, and in the fractures across North America, we see the fingerprints of a world tearing apart. It began with subtle stretching of the crustland that was once compressed and locked began to thin, buckle, and sink. Valleys formed, not small gorges but vast sunken scars thousands of kilometers long. In these rift valleys, new ecosystems were born. Rivers rerouted, lakes formed, and strange environments emerged halfway between the land and the sea. These were places of instability, where the Earth's surface was rewriting itself in real time. In some areas, volcanic eruptions coated the land with thick basalt sheets, turning once fertile soils into barren wastelands. In others, magma rose quietly, filling cracks and hardening into jagged black rock, sculpting landscapes that must have looked alien even to the creatures that roamed them. The breakup of Pangea wasn't just a geological event. It was ecological upheaval on a planetary scale. As the supercontinent began to fracture, climates shifted once again. Where once there had been an endless desert interior, the rifts allowed new coastlines to form, bringing rain and reshaping winds. Forests crept into places they had never been before, and ecosystems flourished in the cracks of destruction. But with creation came chaos. For the animals that had adapted to the brutal monotony of central Pangea's desert, the changing world was catastrophic. Vast regions of their habitat disappeared, swallowed by sinking rift valleys or drowned beneath rising inland seas. For others, the new environments brought opportunity. Lush wetlands, fertile deltas and coastal plains where life could diversify and evolve in ways it never had before. The very first hints of what would one day become the Atlantic Ocean began here, in the slow violence of Pangea's collapse. Picture an endless line of volcanoes, fountains of fire erupting in the rift, spilling glowing rivers of molten stone that hardened into new crust. Over millions of years, the cracks widened. Water from ancient seas seeped in, carving new coastlines. At first, they were shallow, swampy, filled with brackish water teeming with strange amphibians and reptiles. But as the rifts deepened and widened, the beginnings of an ocean formed, a narrow strip of water that would one day expand into the mighty Atlantic. To stand in this world would have been to witness Earth mid-transformation, caught in the act of breaking itself apart. Imagine the ground splitting beneath your feet, not in the sudden catastrophe of an earthquake, but in the slow-motion violence of geological time. Valleys opening, volcanoes rumbling, landscapes changing across centuries, but felt in subtle tremors and rivers of fire that reminded every creature of the instability of their home. And all the while, deep beneath the crust, the mantle pushed relentlessly. Hot plumes of molten rock surged upward, forcing the land to stretch further and further apart. These were the first signs that Pangea's reign was ending, that no matter how massive, no continent could resist the restless churning heart of the earth forever. Yet in this destruction, life found new ways to survive. Crocodile-like reptiles lurked in the swampy rift valleys. Primitive mammals scurried in the underbrush of new forests forming along the coast. Dinosaurs, adaptable and resilient, began to spread across the shifting continents, thriving in environments their ancestors could not have endured. What had begun as destruction became the seedbed of new evolutionary triumphs. Still, There must have been moments, millions of them, when the Earth felt unstable, unpredictable, terrifying. Imagine the night sky over Pangea in these times. A black canvas lit by stars, but at the horizon, a glowing red smear where lava fountains erupted endlessly, where entire landscapes burned in orange light. Smoke and ash would have hung in the air, carried by winds across thousands of kilometers. To breathe in these regions was to taste sulfur, to smell fire. Entire populations of animals would have been displaced, wandering across an earth that was literally splitting beneath them. This was the paradox of Pangea's breakup. Destruction and creation, death and opportunity, locked in a dance that would shape the continents as we know them today. What we now call Africa and South America once fit together like puzzle pieces, welded by ancient mountains. But as the rift widened, as fire and water carved the land apart, they began to drift away from one another, carrying with them the seeds of separate histories. And yet, even as the cracks spread, Pangea was not gone. It was still massive, still dominant, still a world where creatures roamed from pole to pole. The breakup was only beginning, a whisper of the titanic changes that lay ahead. But for those who lived it, those who felt the tremors underfoot, who witnessed the fire erupting from the ground, who adapted or perished as their world transformed, it was nothing less than the end of everything they had ever known. The earth was breaking itself apart, and it would not stop. Beneath the dense forests, the endless deserts, and the sprawling swamps of Pangea, another world thrived, hidden, relentless, and as ancient as the continent itself. It was a world of shadows and pressure, where titanic forces moved slowly, invisibly, but with a power that dwarfed even the fiercest storms. The supercontinent was not a static slab of rock. It was alive, in its own way, restless, constantly groaning and shifting under the weight of forces far beneath its crust. Picture it, an ocean of molten rock, stretching deeper than any human mind can truly comprehend, seething with heat left over from Earth's violent birth. This was the mantle, a place where stone behaved like liquid over millions of years. Here, convection currents churned like the vast lungs of the planet, drawing heat upward and pulling cooler rock downward. The surface we call Pangea was merely the thin, fragile skin resting atop this chaotic, glowing interior. But that skin was never still. Beneath it, invisible cracks spread like scars, splitting apart, colliding, or grinding sideways against one another. These were the hidden battle lines of Earth's crust faults and rifts that could, at any moment, unleash fury on the surface above. Volcanoes, earthquakes, tsunamis, all were born in these deep, silent wars. To live on Pangea was to walk upon the battlefield of the Earth itself, often without knowing it. Now imagine standing on a flat expanse of desert somewhere in the interior of Pangea, where the land stretches for thousands of kilometers in every direction. There are no mountains on the horizon, just an endless sea of sand and heat haze. You might think this land is lifeless, eternal, immovable. But deep beneath your feet, the crust is slowly pulling apart, stretching like taffy under the invisible tug of the mantle below. The rift begins so subtly you wouldn't notice. A hairline crack here, a shifting of groundwater there. But over thousands of years, that crack becomes a scar, then a wound, then a valley splitting the land in two. Whole ecosystems would be caught in the middle of this transformation. Forests collapsing into widening fissures. Rivers rerouted by rising volcanic ridges. Animals forced to migrate, evolve, or perish as the land beneath them reshaped itself. It wasn't just life that adapted to Earth. It was life that bent to the secret tempo of the planet's crust. Pangea's heart, the vast interior far from any ocean, may have seemed stable on the surface, but underground it was riddled with volcanic arcs. Massive chambers of magma simmered for centuries, sometimes millennia, before they finally erupted in explosions so massive they turned skies black for years. Imagine forests of towering ferns, giant amphibians, and lumbering reptiles suddenly shrouded under a thick, choking darkness. The air itself would turn to poison as sulfur and ash rained down. Daylight would vanish. Crops would wither. The survivors would stagger under skies of fire and shadow, never understanding that it all began beneath their very feet. Some eruptions during the time of Pangea make modern disasters look like sparks from a campfire. We're talking about lava flows that stretched for hundreds of kilometers, swallowing valleys, forests, and rivers in glowing seas of fire. Entire landscapes would be erased in a matter of weeks. It is believed that some of these volcanic outpourings, like those in the region we now call Siberia, pumped so much gas into the atmosphere that they poisoned the oceans and triggered mass extinctions. And then there were the earthquakes. No modern skyscraper, no steel bridge, no engineered marvel of today could have withstood the colossal quakes that rippled across Pangea. When continents collide or tear apart, the ground does not simply shake, it rips open. It heaves. It swallows everything in its path. Imagine standing in a swamp full of ancient amphibians, hearing the ground groan like a wounded beast. The trees around you sway and collapse. Water surges as if pulled by a phantom tide, and the ground beneath your feet splits apart into a yawning chasm. This was not a rare occurrence on Pangea. It was the natural rhythm of its restless body. But the wars beneath the continent weren't just destructive. They were also creators. Mountains were born from the clash of plates, jagged peaks rising over millions of years as two landmasses ground against each other. The Appalachian Mountains, for example, were far higher and younger during Pangea's time than the worn-down ridges we see today. Imagine them then. Towering, snow-capped giants rivaling the Himalayas. Their roots anchored deep into the crust like spears driven into the planet's body. The shifting mantle also created the great rift valleys and basins that became cradles of unique ecosystems. Lakes the size of seas formed in the fractures, creating pockets of biodiversity unlike anything else on Earth. Life was shaped, redirected, and sometimes obliterated by these ceaseless battles underfoot. Evolution itself was guided by geology's invisible hand. Even the oceans, the Panthalassa, the greatest ocean the planet has ever known, were ruled by these hidden wars. When plates shifted, coastlines rose and fell. Shallow seas appeared where once there was land, and land rose where there once was water. The creatures of the sea, massive fish, coiled ammonites, early marine reptiles were dragged into this cycle as their habitats shifted, vanished, or multiplied. The scars of these ancient battles are still etched into the earth today, hidden in the rock layers and fossil beds, waiting for us to uncover them. And perhaps most haunting of all, the same forces that united Pangea were also plotting its destruction. The slow churn of the mantle beneath the crust was already at work, splitting the supercontinent apart even as it thrived. Like a ticking clock buried beneath the soil, these invisible wars were marking the countdown to Pangea's eventual shattering, a process that would give birth to the world we know today. Beneath the forests, beneath the deserts, beneath the seas and swamps of Pangea, Earth's heart beat with fire. It never slept. It never stopped. Every mountain, every river, every species that walked the surface was just a temporary passenger atop a restless, writhing beast. And the beast was patient. Beneath the edges of Pangea, where the land met the world's first super ocean, the waters of Panthalassa stretched endlessly, a vast, dark mirror reflecting the chaos and wonder of the supercontinent. Unlike the oceans we know today, Panthalassa wasn't dotted with islands or broken into smaller basins. It was one continuous body of water, an unimaginable expanse that wrapped around the landmass like a colossal ring, hiding mysteries that we are only beginning to comprehend. Imagine standing on the jagged shores of Pangea's eastern coast. Waves crash endlessly, driven by winds that whip across thousands of kilometers of open water. The ocean is dark and cold, churned into frothy turbulence by massive storms fueled by the supercontinent's extreme climate. There are no human harbors, no sailing ships, no familiar coastline. Just an endless horizon, broken occasionally by volcanic islands forming as magma pierced the ocean floor, spitting fire into the sky. Beneath the waves, Pangea was teeming with life, yet utterly alien to us. Giant marine reptiles dominated these water sharks 3 times the size of modern great whites. Ichthyosaurs slicing through the water with torpedo-like precision, and plesiosaurs gliding like shadows beneath the waves. Ammonites spiraled endlessly, their shells forming drifting forests beneath the surface, while plankton, invisible yet vital, fueled the engine of an ocean ecosystem unlike any today. The currents of Pangea were driven by a climate vastly different from our own. With Pangea so massive, heat distribution across the planet was uneven. The interiors baked in intense heat, while the ocean carried cold from the poles, creating violent currents and temperature extremes. These currents didn't just move water, they transported nutrients, plankton blooms, and even massive storms that could sweep across coastlines with no warning. A single hurricane could form over one part of the ocean, and in days, deliver relentless rain and waves to a coastline thousands of kilometers away. And then there were the hidden dangers beneath the surface. Submerged volcanic ridges rumbled with activity, occasionally rupturing and releasing superheated water and toxic gases into the ocean. Massive tsunamis were born from these undersea eruptions. Waves taller than mountains traveling across the endless ocean and striking the edges of Pangea with destructive force. To live near these waters, even as a creature adapted to survival, was to live constantly on the knife's edge between life and annihilation. Yet in these extremes, life thrived in astonishing ways. Coral-like organisms formed the first reefs. Strange shellfish colonized volcanic outcrops, and schools of fish developed intricate, coordinated movements to survive both predators and the ever-shifting ocean currents. The ocean itself was a crucible, forcing evolution to move at a pace almost incomprehensible, shaping creatures whose descendants would dominate seas for millions of years to come. And the sky above Pangea? It mirrored the chaos below. Thunderstorms could form suddenly, black clouds spiraling and lightning dancing across the horizon. Rainstorms would strike the same stretch of coast multiple times in a single day, while distant volcanic eruptions painted the skies with hues of red, orange, and black. The combination of ocean and sky was a constant reminder that life on Pangea existed in a delicate balance between order and utter unpredictability. Consider the smaller details that made this ocean so extraordinary. Sea levels were unstable, shifting with glacial cycles and tectonic events. Coastal lagoons would appear and vanish over decades, creating temporary refuges for life, and then swallowing them again in the next flood. Migratory patterns for marine reptiles and fish were dictated not just by food, but by the very shaping of the earth beneath them, new ridges forming, old ones sinking, creating a labyrinthine undersea landscape that guided life in predation in Pangea was unlike anything today. Apex predators roamed massive territories, some hunting cooperatively in ways that hint at intelligence, others lying in ambush among volcanic reefs. Each encounter was a matter of life and death, as even a small mistake could mean being swept away by a current, crushed by a collapsing ridge, or swallowed whole. And yet, life adapted. Evolution honed its finest tools here: speed, stealth, camouflage, and resilience. Even the chemistry of the ocean played a role in shaping Pangea's world. higher levels of carbon dioxide, shifts in salinity from melting ice and rainfall, and volcanic gas deposits all made the waters volatile, sometimes toxic, sometimes nurturing. Life had to navigate this chemical labyrinth, forcing species to evolve remarkable tolerances or face extinction. And then, lurking in the deep, were the unknown giant creatures so rarely glimpsed that their existence is pieced together only through fossil fragments. Massive squids with tentacles longer than most trees, predatory fish with armored scales, and serpentine beasts that could coil across entire valleys of water, unseen yet powerful. The ocean was a world within a world, vast and secretive, shaping the fate of life on land as surely as any volcano or desert. Pangea, in essence, was Pangea's secret partner, a colossal, living, breathing expanse that mirrored the supercontinent's instability, beauty, and danger. It created the rhythms of survival, dictated evolution, and cast its long shadow over every shore, river, and creature that brushed against its waters. Here, at the edge of the ocean, one can imagine standing alone and listening. The roar of waves, the distant rumble of underwater volcanoes, the cries of massive marine predators breaking the surface, an orchestra of chaos, life, and raw power, as if the planet itself were awake and aware, daring anyone to challenge it. The climate of Pangea was not gentle. Imagine a world stretched so vast that its very size warped the circulation of air, water, and energy across the planet. Unlike today's Earth, with oceans buffering temperatures and continents breaking up the winds, Pangea's sheer enormity amplified every storm, every gust, and every seasonal swing. From one edge to the other, the weather could shift violently in a matter of hours, catching creatures off guard, testing their resilience, and reshaping ecosystems overnight. The central deserts of Pangea were scorching and relentless. Winds swept endlessly across barren plains, lifting sand in blinding clouds that could strip flesh from the bones of animals foolish enough to linger. These weren't mild breezes, they were gusts that could uproot young trees, carve deep furrows in the soil, and shape the landscape as effectively as rivers or tectonic movement. Imagine being a small mammal scuttling beneath the sparse cover of ferns, the wind howling like a predator above, carrying with it particles of rock, sand, and dust that sting every exposed surface. Near the coastlines, the situation was no less extreme. Pangea and the Tethys Ocean funneled massive storms toward the edges of the supercontinent. Monsoon-like systems formed as moisture-laden winds collided with the vast continental interior, creating torrential rains that could last for days. Rivers swelled and burst their banks, drowning forests, washing away soil, and creating temporary inland seas. And yet, these storms weren't uniform. In some regions, the air remained calm and blistering, with temperatures soaring under a relentless sun, while just hundreds of kilometers away, the land could be lashed by storms of almost apocalyptic intensity. Lightning was a constant threat. Massive thunderstorms, fueled by extreme temperature gradients between the interior deserts and the coastal oceans, produced strikes so powerful they could ignite entire forests in a single flash. Volcanic activity amplified this danger. Ash and gas ejected from eruptions mixed with clouds, creating a volatile atmosphere where lightning danced unpredictably, illuminating rivers of lava and the silhouettes of enormous reptiles and amphibians scrambling to survive. Seasonal changes were dramatic. Winters in the poles were severe and prolonged, with glaciers extending far into the supercontinent, while summers in the interior baked the deserts under an oppressive sun. Monsoons and storm systems were unpredictable, sometimes delivering months of rain followed by droughts so harsh they cracked the land. For every ecosystem that adapted to the heat, there was another that struggled to survive the flooding or freezing extremes. Cyclones and hurricanes, if we call them that, would have been monumental, fueled by the immense size of Pangea and the temperature contrasts between sea and land. These storms could have spanned hundreds of kilometers, flattening forests, tossing enormous reptiles like toys, and sending waves crashing inland far beyond the shoreline. For flying reptiles, storms meant peril. For marine predators, the oceans became chaotic maelstroms. Even creatures that thrived in water had to contend with currents and tidal surges reshaped by storm energy on an unprecedented scale. But wind and rain were only part of Pangea's climatic drama. Temperature swings were extreme. In the deserts, daytime heat could be suffocating, while nights brought freezing cold, forcing nocturnal and diurnal creatures to develop sophisticated survival strategies. Burrows became refuges not just from predators, but from climate itself. The giant amphibians and reptiles adapted with tough skins, protective scales, and behaviors designed to avoid the deadliest extremes. Imagine standing on a cliff overlooking a vast Pangean plain as a storm approaches. The sky darkens, clouds swirling into impossibly high funnels, lightning flashing like rivers of molten silver, thunder shaking the ground. Rain lashes horizontally, turning dust into mud, while winds tear across the land with fury. Entire herds of herbivorous reptiles stampede for shelter. Predators follow. Chaos reigns. This was not a gentle, predictable planet. It was a world constantly testing its inhabitants, pushing them to the limits of endurance and intelligence. Even the oceans were affected. Storms stirred the surface of Pangea, generating massive waves and surges that reshaped coastlines, flooded river valleys, and influenced migration patterns of marine and semi-aquatic creatures. Currents shifted, bringing nutrients to some regions and starving others. The weather dictated life, evolution, and survival across every edge of the supercontinent. Volcanoes amplified climate extremes. Eruptions released vast clouds of ash and gas into the atmosphere, temporarily blocking sunlight, chilling some regions while acidifying oceans. Winds carried these materials thousands of kilometers across Pangea, creating unpredictable, almost supernatural patterns of weather. Some areas baked under scorching sun, others plunged into cold, darkened winters. For life, these oscillations were a constant challenge. Insects, reptiles, amphibians, and the earliest mammals all had to adapt to survive the fury of Pangea's storms. Some burrowed underground, others became nocturnal. Some evolved protective features against wind and debris. Vegetation changed as well. Plants with deep roots, tough leaves, or flexible trunks thrived where weaker species perished. Storms, winds, and extreme weather weren't just obstacles. They were architects, shaping every ecosystem, every evolutionary path, and every survival strategy across the supercontinent. And above it all, the sky was alive with energy. A storm might last for weeks, filling the horizon with churning clouds, streaks of lightning and howling winds, before dissipating to reveal a sun so bright it reflected off rivers, lakes, and ocean surfaces like a burning mirror. For those who witnessed it, the weather was terrifying, exhilarating, and incomprehensibly powerful. It reminded all life that the world itself was a force to be respected, feared, and endlessly adapted to. Life on Pangea was a relentless contest between the elements and the creatures that dared to inhabit its vast reaches. Across the supercontinent, from the interior deserts to the frigid poles, survival was not guaranteed. It was earned with every breath, every movement, and every adaptation. Imagine the diversity of habitats. Scorching plains baking under an endless sun, humid swamps thick with mist and towering vegetation, jagged coastlines battered by the ceaseless waves of Pangea, and mountain ranges forming as the land itself groaned under tectonic stress. Every creature had to navigate this labyrinth of extremes, and evolution was the invisible hand guiding their fate. In the interior deserts, where water was scarce and temperatures swung wildly between day and night, life had to be resourceful. Herbivorous reptiles and early synapsids developed strategies to conserve water long, deep burrows that protected against heat and predators, nocturnal lifestyles that avoided the daytime inferno, and metabolic adaptations that allowed survival on minimal hydration. These burrows were more than shelters. They were microcosms of life, entire ecosystems existing underground where insects, small mammals, and reptiles coexisted, competed, and thrived in relative safety. Swampy regions and river valleys, on the other hand, presented a completely different set of challenges. Here, the land was moist, temperatures were high, and predators lurked in every shadow. Massive amphibians stalked the waters, their powerful limbs propelling them silently beneath floating plants, while smaller creatures learned stealth and camouflage to avoid becoming a meal. Trees and plants evolved to withstand the constant moisture, some growing roots so dense they formed natural barriers against floods, others developing leaves that repelled excess water. Life in these wetlands was a balance of hunting and hiding, a delicate dance between predator and prey, each step dictated by the rhythm of the environment. In coastal regions, creatures faced both land and sea. Shorelines were constantly reshaped by tides, storms, and volcanic activity. Marine reptiles patrolled shallow waters, leaping onto beaches or rocky outcrops to hunt or bask, while smaller creatures scavenged debris left by the waves. Saltwater and freshwater mixed in complex estuaries, producing pockets of biodiversity where evolution experimented endlessly. Crustaceans, mollusks, and early fish adapted to the dynamic conditions, their survival often hinging on the subtle interplay between currents, tides, and predator activity. Highlands and mountains added another layer of complexity. Pangea's mountains were often steep, unstable, and tectonically active. Species that lived in these regions had to be agile and adaptable, capable of navigating rocky terrain, avoiding landslides, and enduring temperature swings that could freeze water in the mornings and scorch it by midday. Plants developed hardy root systems to anchor in rocky soil, while animals evolved climbing skills, keen eyesight, and efficient respiratory systems to thrive at high altitudes. The mountains were not just barriers. They were crucibles, forging creatures that could survive under pressure, literally and figuratively. Predation was a constant, shaping every aspect of life. Giant reptiles patrolled the forests, rivers, and plains, their hunting strategies honed over millions of years. Smaller species adapted by becoming faster, more elusive, or developing protective features like spines, shells, or camouflage patterns. Life was a chess game played on a scale that we can barely imagine, with survival strategies evolving in response to threats that were both immediate and relentless. Even the tiniest organisms felt the pressures of Pangea's extremes. Insects evolved to survive both heat and cold, drought and flood, predation and competition. Many developed wings or other mobility features to escape danger, while others burrowed, hid, or synchronized life cycles to match seasonal patterns. Microbial life, too, adapted to shifting soil compositions, temperature fluctuations, and the constant influx of nutrients from volcanic ash and decaying plant matter. Every organism, no matter how small, was part of a vast network of survival strategies. And then there was the interconnectedness of ecosystems. A drought in the interior deserts could trigger migrations, forcing predators to follow prey, altering the balance across multiple habitats. Volcanic eruptions and storms could decimate local populations, creating opportunities for others to thrive. Evolution was not linear, it was a constantly branching, dynamic system shaped by both environmental pressures and chance. Life on Pangea was a delicate dance of adaptation, competition, and resilience. Some adaptations were extraordinary. Certain reptiles developed extended limbs to traverse shifting sand dunes. Others evolved sophisticated sensory systems to detect distant predators or prey. Plants released chemicals into the soil to hinder competitors or attract pollinators. Life on Pangea was never static. It was always responding, learning, and reshaping itself to survive the extremes of climate, geology, and predation. And yet, despite the harshness, there was beauty and ingenuity in these adaptations. The world of Pangea was a theater of survival, where creatures, plants, and ecosystems interacted in intricate, breathtaking ways. Every migration, every hunt, every bloom and leaf represented not just survival, but the triumph of life's ability to adapt to unimaginable pressures. Even today, we can trace these strategies in the fossils, sediment layers, and geological formations left behind. Each discovery offers a glimpse into a world that was brutal, magnificent, and endlessly fascinating. Life on Pangea thrived not because it was easy, but because it was relentless, creative, and resilient, a testament to the power of adaptation in the face of a supercontinent's immense challenges. Thanks so much for watching. Tonight, we explored mysteries beyond time and space. And if your mind is still buzzing, that's exactly where it should be. If you're curious for more, check out our other videos filled with history, science, and the unknown. Drop a comment to share your thoughts, or tell us where you're watching from. If you enjoyed this journey, tap like and subscribe. It helps our little exploration reach more curious minds. Keep wondering, keep imagining, and let every story take you further than you ever thought possible.